All right, I realize you've had a bunch of videos from Mr. Fair. It's only fair that you are now subjected to my voice too. So we're going to take a look at the last problem, problem D, and try to connect things together. So this is a slightly tougher investigation in that the first 5 sections, not too bad, because you can just draw it out like I did here and figure out the correct surface area. The volume is pretty straightforward. Amount of garbage, love decomposing garbage, and the worms, the best part of the whole thing. So the big question is, what is the connection between the surface area and the scale factor? What is the connection between the volume and the surface area? And what is the connection between these things and the scale factor? And Mr. Fair described how you would go about solving these two. So I want to paraphrase this again. So essentially, we realized that the scale factor, say for this one, is 2. And we learned in stretching and shrinking that the scale factor squared is how many times bigger the area is. Well, okay. So the scale factor squared, so that's 2 times 2, which is 4. 4 times the original area, 16, is 64. Well, we could do the same thing here. The scale factor squared, 4 squared is 16. So 16 times 16 is 256. Well, we worked backwards here. Well, we took this number, we divided it by 16, and then we took the square root, squirt, and to get the scale factor. So what we're doing every time is we're taking the scale factor, we're squaring it and multiplying it by the original area. So if we have a scale factor of F, one of the best letters in the alphabet, definitely, all I'm going to do is I'm going to square that scale factor and then multiply it by my original area. So we end up with 16F squared for the area, the surface area of any 1, 2, 3 box that we make based on a scale factor of F. Using that logic for the volume, well, volume is in 3 dimensions, so therefore it would be the scale factor cubed times bigger. 2 cubed is 8. 8 times 6 is 48. 3 cubed is 27. 27 times 6 is 162. So what are we doing each time with our scale factor? Well, we are cubing it, and then we're multiplying it by the original volume. And so that can, and then the volume of garbage decomposed has to do with the volume of the box. So again, that's going to be the scale factor cubed times the original. It's an ugly 0, sorry. And then same here. Well, the original is 1,000, and we're multiplying by the scale factor cubed. So there we go. So now, if both boxes had tops, would the relationship of the surface area change? Well, not really. I mean, we'll still have the scale factor squared times bigger, but instead of having an open box, we'd have an original area that's a little bit bigger. In fact, this area right here would be 2 by 3. 2 times 3 is 6. So then the original area would be 22. So then for question 2, we would have the equation of 22F squared. For 3, how is the volume of those related to that? Okay, well, the volume is going to be the scale factor cubed times bigger. So the scale factor is 4. 4 cubed is 64. 4 times 4 is 16. 16 times 4 is 64. So the volume would be 64 times bigger. How is the amount of decomposed garbage related to the volume? Well, it's the same thing. It's going to be the scale factor cubed times bigger. So here's what you need to get out of this. This investigation gave you a nice little idea of a composting box, and connected the idea of composting box with scale factor and area, which you've seen before in stretching and shrinking. The extension is we're now connecting the idea of a 3-dimensional geometry. And the reason why this makes sense, is let's say we have a box. Let's call it a 1, 2, 3 box. When I apply a scale factor, let's call it f, we're going to have to multiply the side lengths by that value of f. So we'd have 1 times f, which is 1f, 2 times f, which is 2f, and 3 times f, which is 3f. So then we'd have 1f times 2f times 3f, f times f times f. Well, let's reorder things, because multiplication, we can do anything, we can do any order and it doesn't change the meaning. So we still have our 1 times 2 times 3, but we also have f times f times f. Well, that's just f squared, or f to the third power, right? F times f is f to the third power, and 1 times 2 times 3 is 6. So that makes perfect sense why this equation is the way it is. So I'm sorry that I'm not with you today. I would much rather be in the classroom, but I hope you understand why we're not there, and I will talk to you tomorrow.